In March 1986, at modeling events across the country, a revolutionary aircraft and concept were introduced. The concept, an easy-to-build, easy-to-fly sport jet that did not require the detailing of a scale model. The aircraft, the Bob Violett Sport Shark. Originally available in only one version, the Sport Shark met with such popular acceptance that 2 other configurations are now available. By stretching the fuselage 2 inches and sweeping the vertical fin, the Sport Shark swept fin was introduced. The latest, featuring the lengthened fuselage and a military-style vertical fin, dressed here in full camouflage, we present the Aggressor. Bob Violett Models is proud to present the state-of-the-art inducted fan technology, the highest performing model jet aircraft on the market today. Ladies and gentlemen, the Bob Violett Sport Shark. The tremendous power capability of the Biojet fan unit gives the Sport Shark the capability of climbing out approximately 4 seconds after the initial throttle up. This allows the Sport Shark to utilize the smallest of flying sights. And for those of you flying from a grass strip, relax. The Sport Shark doesn't recognize the difference. Clocked at speeds exceeding 160 miles per hour, the Sport Shark enters into a performance class never before explored in the history of ducted fans. The Aggressor demonstrates the handling capabilities with a high-speed 360-degree turn into a rolling vertical exit. With its thrust-to-weight ratio approaching 1-to-1, the Sport Shark defies the law that has required ducted fans in the past to maintain full power throughout the flight. Approximately 1/2 power is all that is required for most turnaround maneuvers. Listen closely and you will hear the throttle advance to full as this Sport Shark completes the turnaround sequence. In the climb out following the maneuver, Bob will select the appropriate altitude for exit and again bring the power back. For this maneuver, he will leave the power reduced. The maneuver? A snap to snap, rarely seen in ducted fan flight. The Sport Shark handles it without difficulty. The swept fin also returning to demonstrate its low-level, high-speed 360-degree turn. It is important to note at this time all versions of the Sport Shark perform identically. While leading the industry with its extraordinary performance, the Sport Shark will demonstrate another totally unique feature: slow flight. approximately 40 miles per hour, the Sport Shark will perform a horizontal figure 8 without any tendency to drop a wing. This demonstration has given pilots the world over confidence in the Sport Shark's ability to comply with standard sport flying, landing, and emergency landing procedures. Available soon from Bob Violett models will be an exact scale F-86 and a F-16. Mr. Bob Violett.
Brief explanation of the fuel system. We have two what we call saddlebag fuel cells, one here and one on the other side of the airplane. These are specially molded fuel tanks such that they fit between the tailpipe and the fuselage, very close to the center of gravity of the model and on the same level as the carburetor. This fuel system is used in parallel and negates the need for any kind of an accessory or external pump on the engine. We use pressure from the pipe tapped off of the high point of the pipe into this T-fitting, two equal length lines into the overflow or vents of the tank, and then two equal length lines from the tank into this T-fitting and then into the needle valve assembly. So to fuel the airplane, we disconnect just short of the filter and we'll pump into the fuel lines. The tanks are 9 ounces apiece, for a total of 18 ounces, and a flight duration of 8 to 8.5 minutes with enough reserve to make a go-around or 2 or 3 if necessary. The tanks are translucent and we can watch the fuel rise in them. The overflow will go back into the pipe. We'd like to stop it just before it does, pull a little pressure back on the pump, and we can disconnect from the pump system and reconnect to the engine. To prime the engine, we have the radio on and we open the throttle, disconnect one of the pressure lines, hold your finger over the other one, and have your helper hold the tail of the model up a little bit. I'm going to raise the model, please. Now we're going to blow into this pressure line. It'll cause fuel to come up, go through the needle system and into the carburetor, and put a little fuel down into the engine to start. See the fuel come through the line, reconnect the pressure line, and close the throttle. Maybe run it open 1 or 2 clicks for starting. To start the Viajet, we have a special rod here that uses a ball end hex drive, a steel shaft, a brass bushing, and a cone that you apply the starter to. The push-in door on the side of the airplane is spring-loaded. It's just a piece of carbon fiber. We insert the rod through the door. You can look down through the inlets and guide the starter into the rotor bolt, the rotor retaining bolt. Now with the throttle set, a few clicks from closed rather, just a few clicks open, apply the glow plug heat, a regular 12 or 24 volt Sullivan type of starter. Hold the rod with one hand on the bushing, Hello, jet model enthusiasts. I'm Bob Violett. I'd like to spend a little time with you explaining what we've done here for the last so many years, developing a Viojet power system and a series of kits that complement it. I'm going to first just give you an overall view of the kit, and then we'll spend some time looking at each individual part and try to explain why we did it, why it's a little different than what's already on the market, and how it can benefit you. Basically, we have a fiberglass group of parts here: the fuselage and the associated hatches, the inlets and the inlet lips, and the tailpipe sections. There are two sections. We have a clear plastic canopy option. We have the flying surfaces. All of the flying surfaces of the model are pre-built. These are the wings, the fin, the two stabilizers, and then we have die-cut parts that go in and form the formers in the fuselage, provide us with formers and mounting devices, strakes, wheel well liners, etc. The rest of the wood products for the elevators and the rudder, and some leading edge pieces and some filling balsa, a few plywood parts. Then we have an entire group of carbon fiber parts that are specially made for this kit. This is what's very unique, and that we're using carbon fiber structure in this kit more so than has been done in the past. So we'll explain each of these parts and what they do. We have a very complete accessory package, the usual hinges and bolts and nuts and stuff you're used to. And then we have a set of injection molded carbon fiber parts that we developed especially for this kit. And these items form what we call the hatch attach system and the cowl keeper system that's used for access to the fan. Now, everything that I'm going to explain to you is already done in our very, very complete instruction manual. We have an introduction section, we have a warning and be careful section, we have how to sand the model, how to paint the model, etc. And then we get into this written description, and the most important part are the drawings here, the very comprehensive assembly drawings. Each step of the assembly, a lot of which I'll show you here during this film, is illustrated here in step-by-step assembly. There's no need for full-size plan with this model because the wings and tails and fuselage is already built for you. So remember now that everything that we talk about has been illustrated, described in a narrative, as well as described in photographs. At the end of the manual here, we have a series of photographs that describe which each of these drawings describe, only showing you the completed portions of the model and some more narrative description of each part. We even go so far as to give you what we call a first flight precautionary profile on how to get this model up and down on the first flight and be successful with it. Now, in particular, let's examine the fiberglass work. We're very proud of this work. It is done by a fellow that works for us named Bob Brown. He looks at each piece of work as a expression of himself and as a work of art. And when you take this thing out of the box and you look at it compared to anything else you've ever had, I think you agree that Bob really does a super job. Now, before we got to producing the fiberglass parts, we spent an awful lot of time on the plug, or what they call the buck, putting the detail and the special features into that plug that would show up in the mold, that would make your hobby and a lot more enjoyable, less frustrating, and a more pleasurable experience in assembling this model. For instance, the hatch that is so important on a ducted fan model, the top hatch is molded as a separate piece. Now, heretofore in some kits, you have to saw this out, and then you would have to go in here with balsa wood and reform all of these flanges. Well, because we went to the trouble of molding it separate, these flanges are already formed on both the fuselage and the front and back of the hatch. So that saves you days of work right there. The hatch access panel for the radio and the retract in the nose of the airplane is also a separate piece. So you don't have to cut that out. And even the location and the clearance slots for the retract unit is scribed on the mold. Closely at a nice feature, you saw the airplane being started. We inserted a starting rod through the side of the fuselage, and the location and the form of that particular push-in door is molded in detail on the fuselage, such that you cut out this little rectangular section here, and you attach this piece of carbon fiber like so, and now you have a spring-loaded door that will push in and close automatically for the starting sequence. The alignment of the wing panels is very precisely molded into the fuselage. Now, this means that when the wing is aligned, and we actually use the fuselage as a jig to glue the two wing halves together, that the wings are absolutely aligned perfectly from left to right, both in pitch and in twist. In other words, they are absolutely perfectly aligned by the fact that these molding recesses here are done correctly for you. The necessary cutout for the wing access panel, or the panel that glues onto both sides of the wing, is scribed on the mold, as you can see, so it's easy for you to cut it out. We don't want you to have to figure out how to do this or where to do it. We've done it for you. We very precisely molded the location of the stabilizer spar inserts, and very importantly, we've molded these dots on the side of both sides of the fuselage, where the leading edge and the trailing edge of the stabilizer and elevator are lined up with these dots, guaranteeing you that the stab is on at the correct incidence angle. For the swept fin and aggressor version, we have molded the base rib pattern that matches the fin onto the top of the fuselage. So you just glue the fin right on here, and this gives you perfect alignment left and right of the fin. So what we've done here is we have guaranteed you a straight airplane, and that we molded, or we built the wings in molds, and then we gave you the alignment indices and saddle on the fuselage for the wing and tail. It's very difficult to build a crooked airplane with this system. Canopy detail is also scribed on the mold and therefore transferred onto the part that would allow you to just paint the canopy as it is, a fiberglass part, or cut out on these lines and replace with the clear plastic canopy that's provided in the kit. This is a nice option if you want to do some cockpit detail work, or in the most simplest case, just leave it off. In viewing the fuselage, undoubtedly you've noticed some yellow panels in the fuselage. Well, this is a space-age material that has a lot of strength in it, very good compressive strength and tear strength, and we've put these panels of Kevlar, DuPont's Kevlar, where we felt most necessary for, the maximum durability of the model should a bad landing occur. Kevlar is lighter than fiberglass. It's extremely expensive, and it's very difficult to cut, so that's why we can't make the entire fuselage out of it, but we use just the right amount where necessary to help make a better model. So that's the fuselage. And the other nice thing about good fiberglass work, and we'd like you to compare this, if you can pick the fuselage up at the show or next time you attend a fan fly and you sight down the side of the fuselage, on anybody's model you're going to see ripples, but not on our model. So we spend a lot of time block sanding out the plug and polishing the mold such that there are no ripples or defects in the sides of the fuselage. That's just a little bit of craftsmanship we like to pass on to you, and so that if you have the painting expertise and the time to do it, the model will be as good as you can possibly make it. We're giving you the model without ripples and defects. Okay, some more of the fiberglass components, and probably the most important part of any ducted fan or jet-powered any kind of airplane is the inlet system. Up to this point, this has been the most neglected part of ducted fan-powered airplanes. Some kits don't have any kind of inlet system in them, and when people ask, well, why does your airplane perform better than the others? They think, well, maybe it's just the airplane design, or it's the engine design, or it's the fan design. Actually, it's everything. But unless the inlets are designed properly and then molded such that you, the modeler, can install them without necessarily having the knowledge of why they work, the model is just not going to perform. So we went through a lot of work and a lot of trouble in engineering and designing and then molding and reproducing for you in a kit the complete inlet system. Now, every cross-sectional part of this inlet, every volume, every turn, every twist is very important, and it took a long time to develop this technology in the model airplane and pass it on to you. Very important also, besides the inlet tube itself, is the inlet lip, the very important curvature. Now, besides the actual inlet tube itself, and in of course the case of the Sport Shark, we have what we call a bifurcated inlet, or inlets that bring air in from both sides of the fuselage and are joined inside. A very, very important part of the inlet system is the inlet lip, and we mold this lip for you out of fiberglass in left and right pieces. And this lip is important, especially at slow speed, where we're trying to accelerate the model, in directing the air from the outside of the fuselage to the inside of the inlet duct itself. And you can see here against my jacket, you can see the cross-sectional shape of that lip. It has a very important curve. There's actually two curves involved there from a highlight on the outside. Now, this inlet tube has a recess molded in it on the inside here, and that inlet lip actually fits or keys into that recess. Now, we showed you the recess molded in the inlet tube. We also have a little step molded on the fuselage. Now, your job here is to cut out this section, and the cutout line is scribed for you, and you will leave this little step here. And after you've done that, then this inlet lip again will fit on the outside of that and join up with the inside that we showed you previously. Now let me show you what that looks like in the assembled stage. This is a partially assembled model. We'll refer to it a number of times in this presentation. And right now we'd like to show you that what I was just talking about with the inlet lip glued onto the fuselage, and then also the inlet liner itself glued inside the model, and how the lip very precisely joins the inside and the outside. Now, the reason that's so important is when the model is accelerating or standing still at full power, a properly designed inlet will actually pull air all the way from back here on the fuselage, and that air wants to negotiate that corner and come in and feed the engine. If that corner is sharp, it can't negotiate it, and it will separate severely off of that lip, causing a tremendous separation bubble in the inlet, and require that you either cut a hole in the bottom of the model or make the inlet larger. So as the model accelerates, this air is coming off the side of the fuselage, turning in here. As the model goes faster, of course, the air starts coming in more from a direct frontal entrance. And at full speed, the air is coming straight down the inlet. We'll talk about that more in the flying of the model. Here you can see how the inlets come together and have been joined. A little better view of it. The two inlet halves have been glued together, and they come together in a peak here, and then you can actually see this cylindrical area here. The spinner of the fan actually fits up in there, and the air is fed to the fan blades as precisely as possible. This black wrap that you see around the inlet, that is carbon cord saturated with CA, and that stiffens. It's like forming a very stiff rib on the inlet, and that keeps the inlet from collapsing under tremendous pressure that the fan is exerting on it, or lack of drop in pressure, really. The tailpipe sections that are precisely molded again out of epoxy glass. There is no joint or joining tape in here. We figured out how to mold these things such that you get a one-piece affair. It's very lightweight and very clean. The access hatch to the engine, or the rear of the engine, is very difficult to see on film here, but it is scribed in the mold, and it shows you where to cut that out. Now, the reason we have two sections of the tailpipe is that it's physically impossible to insert it in the model in one piece, so we had to mold it in two pieces. And to make it easier for you, we flared the front part of the rear section such that when you slide the two together inside the model, they will sleeve together just like that, and it only takes a little bit of glue. Now, the shape of the tailpipe itself, the aerodynamic shape of that tailpipe is very important. And you know, heretofore you've been given plywood pieces to roll up or plastic pieces to roll up. Well, the aerodynamics or the laws of physics that air is trying to obey as it proceeds under pressure from the fan down this tailpipe, it's important. And so we've taken the time to make the molds aerodynamically correct rather than just give you a piece of paper or plastic or plywood to roll up. So that's it for the fiberglass portion of the model. Now let's look at what we call the Magna-built or prefabricated, pre-built flying surfaces of the model. The wood group, or the flying surface group of the model now, you receive in the kit two pre-built, or what we call Magna-built wing halves, the fin all pre-built, and the two stab halves. The wings are built, the wings and tail surfaces are built in molds and jigs using balsa wood, a few plywood ribs, a lot of carbon fiber inside the model,